Hey everyone, welcome back, and today let's solve Leetcode problem 2825 titled Make String a Subsequence Using Cyclical Increments, the daily Leetcode challenge problem. So we're given two zero-indexed strings, string1 and string2, and in an operation we can select a set of indices in string1, and for each index I in the set we can increment string1 at that index I to the next character cyclically. And that is a string A becomes a string B becomes a string C rather, and so on and so forth. And the cyclical part of this kind of shifting is that the string Z, notice how it's the end of that pattern, would go back, just take a cyclical turn back to the string A. So we need to return true if it is possible to make string 2 a subsequence of string 1 by performing the operation at most once, and false otherwise. Note, a subsequence of a string is a new string that is formed from the original string by deleting some, possibly deleting none, of the characters without disturbing the relative positions or indices of the remaining characters. We keep the relative order of the characters, we just pick a few from different indices. That's how a subsequence of a string or any data structure is defined to be. So in example 1, we have our input string 1 and string 2 to be the string ABC and the string AD respectively, and we have to output true. Why is that? Well, because we can select index 2, which is going to be a B in string 1, right? And we can increment string 1 at index 2 to become D. And all of a sudden, string 1 would become ABD, and string 2 would then be a sequence of ABD, right? We can get A from here, and we can get D from here, which are both relatively ordered, correctly sequenced elements that are all in string 2. We got all the elements from string 2 and kept their relative order from string 1 and found all those elements in the string 1 data structure or input. And so for that reason, we have to output true. And in example 2, we have string 1 to be ZC, and we have string 2 to be AD. And in this case, we still cannot put true. The reason why is because we can select indices 0 and 1 in string 1. We can increment this C that's next to this Z to become a D. And then we can change this to become an A. So it would be first AC and then AD. And AD, of course, is a subsequence of AD. They're both equal to each other, and a string is considered to be a subsequence of itself, because theoretically it still works, right? You're still keeping all the same elements in the same relative order. It's the exact same thing. And so since string 1 becomes AD and string 2 is also AD, that is going to be a subsequence after those operations, and so we can return true. However, in example 3, we have string 1 to be the string AB and string 2 to be the string D. And in this case, we have to output false, because first of all, no matter what we do, we can never reach D in this case, right? It is simply not possible, right? It can be shown that it is impossible to make string 2 a subsequence of string 1 using the operation at most once. That's very important, okay? We cannot use the operation only once, or at most once, or 0 times, and get a D from this original input string 1. And so therefore, false is returned. So with that out of the way, I will give you guys a few seconds. I'm going to just go over this problem in your head and think of a valid solution. And then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so to solve this problem efficiently, for a quick high-level rundown of our algorithm, we're going to first use a single pointer, or index, if you will, right? And we're going to use this to traverse through the characters of, you know what, I would say string 2, but I'm going to change this to be S and T just for easy access. Okay, right, so just note that, again, S is going to be string 1. And T is going to be string 2. I just changed these for easy access. I literally changed the input parameter names so I could just kind of access them and type them a little bit easier. But anyways, to go back to what I was saying, we're going to use that pointer J to help us actually iterate through all the different characters of string 2, or in this case T. right? And we're going to do this while we iterate over s, or while we iterate over string 1. And as we do this, we have to first check, well, is the current character in s, does it match t at j directly? If it does, well, then we're good, right? Or we have to also check if it can be rotated to still match t at j with that one operation. If all of these characters in t are actually matched before all the characters in s is exhausted, before our for loop terminates, then we can return true. Otherwise, we have to return false. So for a quick reiteration, j is going to be the pointer that tracks the current index or position in t, and s and t are simply our inputs. And we simply have to check the direct equality, right? If the current character is equal to t at index j, or the rotational match, if we apply that operation exactly once to the current index and rotate it to see if it then equals the current t at j, right? And I'll talk about how that actually works a little bit more in the code. So I'm going to actually have a quick base case here just in case, just to avoid any extra computation. So the quick base case here is that if the length of t, or string 2, if it's greater than the length of s, or string 1, we can immediately return false. There's no need to even do any computations here. What is that saying? That means our string 2 is larger or has a greater length than string 1. We definitely, obviously, won't be able to form a subsequence from string 1 of string 2 because we wouldn't have enough characters in string 1. String 2, the actual sequence that we're trying to find a subsequence of in string 1, would simply be too large, right? It would be impossible for t to be a subsequence of s, right? And so we have to immediately return false. This is just too long. We don't have enough characters in string 1 because it's too short compared to string 2 to form a subsequence of the second input. Now let's actually initialize our j pointer, and of course we're going to initialize it to be the 0th value, right? And this is simply going to track the position in t that we need to actually match. So now let's actually start iterating over the different characters in our input string s. So for every, I'm going to say char, it's basically an alias for character. If you guys use languages like C++ or Java, you might see char as a keyword for data types quite often. For every char in our input string s, simply iterating over each character in our input string for each iteration. And now for each iteration, we have to check, well, can we actually get our current character to match t at index j in this iteration? Either it's directly equal to it, or we can get it or achieve it after the rotation, right? How the operation is defined above. So the first check that we have to do is, well, is the current character, is that already equal to t at j? If that's the case, or, and this is where we're going to use our ordinate operations here. I'll explain how it actually works. I'm going to have basically the ord of the current character, right? And what we do with the ord result of this current character, we subtract it from the ord of the string a, and I'll explain this as we go, and we add 1. And once we actually get this result, I want to actually mod this, so I'm going to use the percentage or modulus operator, right? And I'm going to mod it by 26 because that's the number of characters we have in our English language, plus the ord of the string a, and we have to see if it's equal to the ord of the current, basically t at the current index, which we can get from the pointer j, right? So what am I really saying in this really lengthy line of code here? Well, first of all, I'm simply checking, well, does the current character directly match t at index j? If that's the case, well, we're good, right? The characters are already equal without having to actually need any operations. And this is where we actually check for the rotational match, right? And what that means is it basically checks if the character in the string s, when it's shifted by one position alphabetically with that wrapping around cyclical effect, if it matches t at j. And kind of the explanation of this rotation logic using this ordinate, well, ord of char minus ord of the string a simply converts our current character or char into a 0-based index, right? Where the string of a is 0, string of b is 1, and so on and so forth until the string of z is 25. And plus 1 is simply going to shift its index by 1. Right? And when we mod it or take the modulus of it by 26, we're basically making sure that we wrap it around after the string z. That basically saying is that the string of z would become plus 1, right? It would become a, or the string of a rather. And when we add on or plus the ordinate of the string A, we're simply converting that index back into a character. That's what we're doing right here, and we're comparing it with the current ord of the current element at t at the current pointer j, to whatever value it is right now. And if that's the case, if we can actually make this match with either this rotational logic or it's directly equal, we can increment our j pointer by 1. Right? If the character in S either directly matches the current character t at j, or we can actually get it via a rotation, we can move the pointer j to the next element in our character t, kind of simulating that subsequence effect and using that pointer to do so, right? And now we have to actually check, well, if j is equal to the length of t, well, we know we can immediately stop and just already return true. Because if that's the case, that means we've exhausted all the elements in t, which is again string 2. We've found all the elements and made a subsequence of all of them in string 1. J has already hit the end of our second input, string 2, and so we don't need to keep continuing. We've already found our subsequence using the direct comparison or this rotational logic, and we can immediately return true. Right? We're basically checking here if all of the characters in t using this j pointer, if they've already been matched, if it's equal to the number of characters we already have, the length of t, right? And if it actually does, that means the subsequence has been found in string 1, right? And the function would immediately return true. Right? We'd immediately just exit out, we can immediately return true. And if we never return true in this for loop here, we can return if j ever hits the length of t. Right? Again, j is our pointer, and if this for loop here basically finishes without actually returning true, we then have to have one final check, right? Simply where if all the characters in t were matched, basically saying that j is equal to the length of t, and if that's true, we can return true, because meaning that we found a subsequence at the end of this for loop here. Otherwise, we have to return false, and returning j equal to the length of t is going to return a Boolean value depending on that condition. So unless I made any syntax errors here, this should be accepted and this should be a valid solution. And as you can see, this is just about as efficient as you can get. So for a quick high-level rundown of how this algorithm actually works, so essentially, we're simply just considering two cases here for every single character in our input string S, right? We're considering first the direct match of the current character and t at the current point of j, at whatever value it's initialized to in this iteration, and the rotational match after the operation is defined at most once of the two characters. And if that's the case, we can simply increment j by 1 to move on to the next character in our input string t, or rather our input string 2, right? And we're using this j pointer to actually track our progress of how many characters we actually matched in t, and basically iterate over S to actually match these characters in order, similar to how a subsequence is defined, to keep the relative order and arrangement of all the different indices and their elements in our input data structures. So for the time complexity of this solution, this is going to be a big O of n, a linear time solution. N is going to be the length of our input string S, and the reason why is because this is really a one-pass solution, right? We're really just iterating over all the different characters in S exactly once with one for loop here. And all of our operations inside the for loop, right, like this character comparison and this ordinate computations, they're all going to be big O of one runtime operations, right, or constant time operations. And the space complexity is actually, believe it or not, also going to be big O of 1. It's going to be a constant time solution. The reason why is we don't actually use any auxiliary memory here. We're not using any extra data structures to store any elements from our input. We're only using a few integer variables like j, and that's actually really it. So we're not actually using any extra data structures here. We're using a constant amount of extra space for our variables, basically j. So that's going to be it. It's going to be a constant time solution, or a big O of 1. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.